Okay. What if we use the LRAM instead? Does anyone have an opinion without actually doing it because I don't feel like it? What do you think would happen if we use LRAM instead? It would still be 24. Yeah, because like, duh, who cares, right? As long as you let the number of rectangles go to infinity, a little bit of it's not gonna matter. All right. All right. Matteo, I have more things to say. First of all, what I'm actually going to do is, I remember on the very first day of this class when we tried to find the area of a circle and we split it up into like pieces and we kind of said, if we let like the number of like all those wedges like go to infinity, then it'll be like pi r squared, right? Yes. So what's going on is, what I'm actually doing is something sort of philosophically elusive now. What I'm going to do is I am actually going to redefine my concept of area to be this. Okay? In other words, I'm now going to just define the area under this curve to be whatever results from this process of letting the number of rectangles go to infinity. Okay? The last thing I have to say is that this is integration. Whoa. Yeah, as long as we use it in its proper context, yes. This is, loosely speaking, this is integration. Integration is the process, loosely speaking, of finding the area under the curve. Finding the area under a curve. All right, and probably the last thing I want to talk about, which is actually probably the first thing I should have done today, is why do I care about finding the areas under curves anyway? What was the whole point of that?
I think oh wait.
Reach back to the first day of the semester. Why did I care about why did Newton care about the area problem to begin with anyway?
Oh, I have a.
Is it like velocity?
Physics, yeah, okay, be more specific. Yeah, that's right. If I have some velocity curve, suppose this is time 1 and this is time 4, and this is a velocity versus time curve.
Oh
and
my gosh.
What I would like to know is...
I wrote on January 22nd, 2015.
Yeah, I know. Exactly. Yeah. See. Yep. So what was the whole point of the area problem? Matteo, this is the point. The point is, I want to, if I have a velocity versus time curve, and I'd like to know how much total distance was traveled, right? And so what I'm going to do is let's split this up into 3 rectangles just because. So suppose I do that. Then this is time 2. This is time 3. So now, if I find the area of this rectangle, this is a thinking question. What does the area of this rectangle represent? That's not exactly correct. What are the dimensions of this rectangle? What is the width of this rectangle? What does it mean in words? Well, the width. The width is just time 2 minus time 1. If we're doing this in seconds.
1 second.
And we are. Then it's 1 second. In other words, it's like the time which has elapsed, right?
Yeah.
So this is the time elapsed. And what does the height of the rectangle represent? The velocity at time 2. Okay, so can I get now in words, Vani, exciting things are happening. Can I get in words what this rectangle means? Not you, someone else. See, like comments over anything already. Yeah.
The over approximation of the acceleration between times 2 and 1.
No, it's not acceleration. It's the velocity at time 2 times this 1 second. If you multiply velocity by the distance traveled, but specifically what distance? I know you said that, but that's not. But what distance traveled? It's not the actual distance traveled. It's
had been traveling at the speed at time 2 the whole time.
Yes, good. What the area of this rectangle represents is the distance that you would have traveled if over that entire interval you were moving at the speed that you were moving at the right endpoint of that interval. Is everyone cool with that? Okay, and then you just do it again, right? And so this time I'll say it again, but a little bit faster. What does this rectangle represent? Well, it's a time interval times a particular velocity. The velocity being this one. Well, that is the distance I would have traveled if over that entire second I had been moving at the rate at which I was going at time 3. Are you guys getting the hang of this?
Yeah.
And then like et cetera, et cetera. Okay, so the whole reason why we cared about the area problem is because we can figure out the distance traveled for some velocity function. And of course, it will be an approximation only. If I want the approximation to be better, more rectangles, perhaps even an infinite number of them. Okay, awesome. I think I'm good with this. Let's actually stop the camera again for a minute.